Everyone that you ask will say robotics is the future of construction, but not many people can tell you what that looks like. One of the things we discovered is that the most important thing to people using autonomous robots is that it doesn't get stuck. Autonomy is, the whole point of it is that it works all the time, every time. It's on the fly, allows for a very diverse and robust method getting through these dynamic environments. Everything that we do needs to show obvious value to people. Thank you for joining me with the session here. I'm going to go through the format, but first I want to say if you have any questions during the session, if you submit them in the app, then I'll be able to see them here on the iPad. So, lessons learned when developing the Groundhog, which is our autonomous reality capture robot. There's two main areas that the lessons are categorized into. One is more the technological barriers that we encountered, and then the second is more of the implementation or adoption part of it. So in the end, there'll be a challenge for you guys. And but before all that, I want to start out with a little bit of background on who I am and what perspective I'm coming at this with. So SuperDroid Robots is a robotics company, but I am a structural engineer. So I have about 17 years of experience on the design side of buildings. Can I get a show of hands for anyone who works with progress monitoring on construction projects? Okay. Yep. So a few there. So what we learned about what people want to achieve in that is you want to be able to see images at consistent locations throughout the job site. And it could be images or videos, and we want to see that on a consistent basis, so regular intervals of time. You guys are the experts, you're the ones that we're listening to for that, so does that line up with your understandings? What we look at as the goal is, here's the tip of the iceberg, here's what people are telling us, and then there's a lot below that goes into making that possible. So fall back on the structural engineering experience to help understand how construction works. It's a pretty dynamic environment. Buildings on paper seem basic. People have experience with home remodeling and things like that. But when you get onto a construction site, you can see the dynamic nature of everything that goes on. Everyone has their own goals, and eventually out comes a building that the owner is then going to use. So in my experience, I was out of school as a structural engineer. I was involved in a company that was doing a lot of restaurant retrofits. So I was responsible for going out to the field. Sometimes it's a one-day trip in and out in the same day. And then I would be documenting the structure. So I'd have to get above the ceiling tiles, and try to see what was going on in that structure. If it's a 2-story building, I'd have to go above and try to see how am I going to put this all on paper in a way that when I get back to the office, I can still interpret those notes and generate a set of drawings that I'm then going to use to design the building. So I wish that we had this at that time, but what I typically do is you pop up the ceiling and then you try to light up the space and take photos of that. And inevitably, when you get back to the office, you forget where the photos were taken, which direction they were. Maybe you couldn't read some labels as much as you thought you could. And so there's missed data, and sometimes you can never go back out to site in that case, but you have to kind of interpolate the results. So what we tried to do on the reality capture side for robotics is something similar here, where we can basically put people or put cameras where people don't want to go or can't fit. So that was one of the areas that we looked at. But as far as the reality capture on a construction site, we want to view images from the site. We have to be able to handle the constant changing nature of the construction sites. So one day a robot might go into a room and it's empty, and then the next day there might be a man lift there, or there might be tables, or there might be pallets of material. And so it has to be able to still navigate, still get to the point where it needs to take that photo. It needs to be able to avoid obstacles. So that's part of the navigation, but also if there's people walking around or different equipment moving around, it can't hit that. It needs to be able to always complete the mission. So if there's autonomy, that means that there's no humans involved. And that means that it always needs to return to a base station so that it can charge itself and continue to do its job, upload the data, things like that. It needs to be able to charge autonomously. So if it runs out of battery and somebody needs to go out and fix that, then that's not autonomous, that's semi-autonomous. It needs to have an easy setup process. So the people that either we need to have a technology person that's bringing the unit out to the site and setting it up, in which case their time is valuable, that they need to be in and out of the site, or if it's field staff that needs to set it up, it needs to have a low technological barrier in order for that to work every time. Have the option of photos or videos, so different platforms use different things. We started with photos. People have asked for videos also, so we learned about some of the nuances with those, and then also notifications. So even though it's autonomous, people like to know that it's still doing its job. And so interaction with the users and the people around the unit we found was very important. Even on the robot itself, when there were no visual indicators, if the robot was sitting still for some time, there was questions in people's mind as to, is it still trying to do something? Is it thinking? Does it think that there's something in front of it that's blocking it? And so visual indicators on the unit itself, as well as in the cloud, help people respond well to the robot on site. And then our primary focus was on the budgetary issues. So when we started out this process, there was a specific price point that was mentioned by basically everyone that we talked to, that in order to be on every job site, which is the goal of any robotics company, then you need to be below this price point, which is significantly below the other solutions that were out on the site. So we had to achieve more reliable navigation, so a higher functional level, and then we also had to have a lower price point by an order of magnitude, essentially. So the way that we did this was by taking an approach to autonomy that is actually pretty common in other industries. And it's really similar to how we capture buildings with SLAM LiDAR scanners. So essentially what the robot is doing during a mapping phase is it's being driven around the building. And this can also be done autonomously, but right now a user's driving it around the building, so they have some interaction into where the robot should go and shouldn't go. And as it's doing that, it's building essentially a 3D map, so kind of like a LiDAR scan of the space. But it's not just that, it's also recording image data that it's seeing, so that when it sees that in the future, it knows that it's at that spot. It's adding in IMU data, encoder data from the wheels, different things like that, so that it helps it understand the spatial parameters of that as well, and then how it relates to those. So I guess I would say what this allows is basically the map is the map, and then as the robot continues to navigate around, that map is updated. So as things change, if a wall gets added, if a door gets closed, if there's a pallet over here, the map now has all that content in it, and the navigation is then able to route around that. So the algorithms that are used are called A-star, which is similar to it's the same foundational model that is used in Google Maps navigation. And so you basically say, I, the robot, am here. I need to go to this waypoint. So the waypoint may be a place where you want a photo captured, or it may be just help define a route that you want the robot to take to give it more direction, especially when there's not a lot of walls up. You may want to add additional waypoints to help define, all right, I want you to kind of drive in this direction. So the robot says, all right, I know I'm here, I know the waypoint is there, and it's dynamically generating the path to get there. So it takes a global view saying, all right, I need to head in this direction. And then as it's doing that, it's also making local decisions saying, okay, well, I see this here, so I'm going to try to go around it this way. If there's something else found there, then I'm going to go back the other way. And so it allows for a very, it's on the fly, it allows for a very diverse and robust method for getting through these dynamic environments. Now, there are some cases where this still will fail. So if it can't get to a waypoint because it's in an enclosed room and the door is closed, or there's drywall across the doorway, something, or there's a pallet in the way, then there's no way that it can get through through those obstacles. They would have to be moved. And so then in that case, it would need to have some failover options. So one of the things we discovered is that the most important thing to people using autonomous robots is that it doesn't get stuck. Because if it gets stuck, then somebody has to go out and find it and go, somehow get it back to the base station, which, depending on the state that it's in, may or may not be difficult. And it's just another thing to worry about. So they want to make sure that it definitely returns to the base station. If it can't hit a particular waypoint, the desire is that it moves to the next waypoint. And if it can't hit that, moves to the next waypoint until eventually it would return to home every time. And we know it should be able to return to home because it got from there to the position that it's in. So this map that you see, the representation of the map, is constantly updating. And it also is reminiscent of a floor plan. So there have been requests to overlay floor plans, and all that's possible. But this is really the foundation of what allows the robot to navigate in dynamic environments. So it's a little bit more, and a little technical details here, but we will get into the business side of it shortly. So we found that in order to hit the price point that people were targeting, which is in theory the number that needs to be to put a unit on every job site, we needed to lighten up the sensor load as far as cost and power. And so that meant not having a LiDAR unit on the standard unit. And that we found that actually works remarkably well in spaces with a lot of features. So features would be things that it can see on the wall or on sometimes floor, but mostly the wall, where it can identify this is different from that place over there. So it can help it know, all right, I'm in the spot that I think I am based on the IMU and the wheel encoder. So what we did is we put that together in a unit, and then we put it out on job sites. And what we found was that although this type of a sensor configuration works in 90% of building projects, maybe by square footage, the people that were testing, or the companies that were testing these units, were putting them on to test them. We're putting them on very large projects that had budget to do these sorts of tests on them, and would be potentially the first ones that it would be deployed on because of the larger budgets. What came along with those larger projects were larger open areas or long corridors that didn't have a lot of features. So these would be auditoriums or stadiums or large, not tens of thousands, but hundreds of thousands of square foot floor plates that need large corridors that have a lot of doors, so they can look similar from one side to the other. So that sort of a space requires a unit that can see, a sensor that can see out to the edges to help identify where it is. So what we did then was, through various refinements in the generations, is to have the Pro unit, which also has a LiDAR unit on a LiDAR sensor on it. While more expensive, it allows to be used in those sorts of buildings, with the thought that, okay, we'll pilot on, and it's something that we probably should have seen coming from the beginning, because it's a good idea to pilot technology in the most difficult use case and then be able to scale back from there. So the thought was, bigger projects and larger open areas are more difficult, so we should start with that. Another thing that came up, which is kind of interesting, is glass. So there's a lot of projects or buildings now with glass all the way to the floor, which for a human is not a problem because we can see that glass is glass, and we kind of have a context of, all right, well, I can see that it's also the edge of a slab. But the way that the localization part of the navigation works is really looking sideways in a lot of ways. And so glass looks like the outdoors. So it looks like the building continues on past the glass. And so we needed additional sensors that were not visual in order to identify that as somewhere that the robot should not go. And so those are ultrasonic sensors or time of flight sensors, which are shorter range. They can't really be used for localization, but they can be used to say, I'm not going to go through that area that looks open because there's actually an obstacle there that a sound wave from an ultrasonic sensor would bounce back off of. So this gives a little bit more clarity into the field of view of the different sensors and why they might work better than others in different situations. This is some views of the different models that we came to. The generation 1, as I said, was really designed to be the workhorse unit, and we found that we needed to add the LiDAR unit, so we did that in generation 2, and then generation 2 didn't really go out in the field too much because it was more to look at how that worked with the navigation stack, and then generation 3 is really the unit that is the combination of all of it and goes out into the unit. But it might look like we overlooked the pricing issue with that because the price does more than double with that LiDAR unit on it. And we're also to help address that, looking at other options for the LiDAR that would bring the cost down. But I think the feedback that we've seen so far is that, yes, this unit might be for larger projects, but on smaller projects, we can still use the smaller ones. Some videos here, or at least photos of what the unit has looked like on construction sites. The other thing that we learned is that, and I don't know if some of this is that this is the case, but once you actually try to do something, it becomes more apparent as to why that's important. So everyone kind of knows that construction sites are not super clean. Some of them are more organized than others, but there's cords all over the place, right? Cords can trip up a lot of things. They can trip up humans too, but cords need to be addressed, and some of them are big cords. Like in the image here, there's a cable that's about 1.5 inches in diameter that that can't be an obstacle that stops a robot. So we need to be able to address that, which it can. The other thing that we discovered getting out onto the job sites was a lot of the use cases that people had for it to start off were large warehouses, data centers, kind of like I mentioned with the Pro unit, but they're empty at that time. So you go into a warehouse after construction, once it's in use, there's a bunch of racking and shelving, but while it's under construction, every column looks the same essentially, and so that needs to be accounted for, and that's what the need of the lasers was for. A few other pictures here to see some of the different areas that have been tested. One of the other things that we discovered along these lines was that getting onto a construction site is not easy. So there's geography constraints. So we don't have, like in the area that we are in Chicagoland, there's not a lot of new buildings around where we are. So there's some renovations and some new multifamily, but in order to do this testing, you really want to be on site a lot. And so then that requires going to other states or other cities in order to do that. So let's see. So here's where we are so far. So we say that we've learned almost everything, right? You can see the bottom of the iceberg, but this may also be just the tip of a bigger iceberg that we haven't seen yet. But what I wanted to talk about is next, that was kind of the technological things that we learned. The next part is the adoption or the implementation part. So we came here last year, we were here this year, and we get a lot of excitement about robotics. So there's, my wife had to kind of disclose to me that not everyone in the world is excited about robots, but it appears as though everyone in construction is excited about robots, so that's good. It's interesting. It's kind of an interesting part of the industry to be in, because everyone that you ask will say robotics is the future of construction, but not many people can tell you what that looks like, or how we get there, or what are the steps that we can take today in order to get there. And so what we found is that if you ask somebody, a construction company or any other company really, do you want to see a demo of this robot? Almost everyone will say yes. So, it's something that's interesting to look at. It's fun. It's exciting. It's cool to see hard tech in person, to see it moving around. It's fun to imagine some possibilities which may or may not be realistic. But then it becomes, all right, well, what's next? When I go back to the office, what am I supposed to do about this? But my question for you is your company ready for automated reality capture? And the reason I ask that is because it's not just, it's not as simple as buying a drill or even a drone really, but it's really a process, because we're early on in the robotics in construction. There's really been one or two attempts at bringing robotics into construction, and they didn't really end well. So there's a lot of hype that happened several years ago with a new product that you probably all know, but I'm not going to mention it by name. But promises were made of what this can do. It's automated this, it's automated that, and then a lot of those fell flat in most cases, and a lot of money was spent without much result. So what that means from our side is that everything that we do needs to show obvious value to people, but I think it's more than that. So what we've seen is that in construction, as in most industries, there's a whole process of approval up into the CFO or the CEO of the company that, there's approval processes to sign off on money being spent, there's budgets, and there's classic ways of resolving problems. So the most common way to solve a problem or to get something done on a construction site is to have people do it. So everyone is familiar with just add people to solve the problem. If you need to capture photos at the same spot every week or every day, just have somebody do it. If they don't want to do it, we'll figure out a way to make them do it. And to get everyone on board with a change, there has to be, it has to be like an apples to apples comparison, which is impossible. A robot on 4 wheels, or even if it looked like a humanoid, it's not a 1-for-1 replacement of the human that would be doing that task, or the portion of the human that would be doing that task. And so it's important to say, all right, well, what are the risks that are involved with deploying this technology, with buying the technology? There's financial risks, there's safety risks, there's maybe insurance risks, there's what if I look bad to my boss because I suggested this and it didn't work? There's all sorts of different things. And so find out what those risks are, and then see if you can find a way to remove the risks. And that may mean that the first robot that you put on site is not a fully autonomous Groundhog reality capture robot. It might be something more basic, something more simple, something that is lower cost, or that's used for a specific use case that has budget. But the important thing for us is really that as the technology is so early, there's no way that we can, there is a way. there's not a realistic way that we can do full end-to-end testing for millions of hours without it being used by real users. So we can set up mock construction environments, we can test it in our labs, we can do pilots, and we can do demos. We can do all this stuff, but autonomy is, the whole point of it is that it works all the time, every time. That's essentially 100% uptime. That's not something that you can test. It's something that you can, hope to achieve. It's something you can work towards. But if technology companies are expected to do that all by themselves, then the bringing new technologies into construction will take decades longer than if they're able to work with partners in construction that can assist with that. And what that means is, so there's, I don't know how familiar people are with the product adoption cycles, but there's this thing called early adopters, which is essentially bleeding edge. So if you're on the bleeding edge, there's blood. You can't be on the bleeding edge. You can't be the first ones to adopt technology without having some pain involved. That pain could be a number of different ways. It could be financial pain, or it could be, hopefully not direct project impacts, but anything is possible, really. And if you're not the company that is willing to experience that, then it's good to know that and to wait until the technology gets to a certain point where there is no blood. You can still be on the cutting edge, just not on the bleeding edge. So you're on the back side of the knife, I guess you could say. And because what we need, what any robotics company needs, is they need products to be used, and then that's what provides the feedback that improves the product. Otherwise, we're just going to be sitting in our lab testing what we think is needed, and maybe it's not. The more that a product gets used in the world, the better that it can be refined. So if it's not used at all, it's not useful at all. If it's used a lot, and then the feedback that's gained through that process is incorporated into the product, then it can be very useful and a lot more quickly than if it's used less. So that's not to put it on the construction companies or the subcontractors or the service providers. It's really just we're all working towards a common goal, I believe, and that is the future of construction. But we do need to work together on it. So there's not interest by people with money, venture capitalists or private equity, or there's not interest in them to fund a multi-decade R&D project to bring robotics into construction. It has to generate revenue, and it has to generate value, and it has to be beneficial to both sides in order for that to be a successful relationship. And I believe that's the method that's required in order to continue the construction industry, because I think that in the next 5 or 10 years, there'll be, the labor shortage will be pretty apparent, and it might be harder and harder to complete construction projects. So pretty much at the end here, moral of the story is that we have a little animation here. It drives almost like that, except a little bit more stable, I guess. But that we're working on this. We're trying to be a little bit ahead of where the adoption is, but also not too far ahead. So our efforts on the Groundhog, that's not the only product that we have, and it's not the only product that we're working on. We're also working on more moonshot type products like humanoid. We have dog platform, things like that. But what we want to do is not get too far down the product development path before we have users actually using it on real projects beyond pilots, so that we can develop the product that meets those requirements. But I also want to reiterate that identifying the risk, because inevitably what happens is we say, okay, here's a final solution, and then you go back to the office with questions in your mind. Well, what if this? What if that? you try to pitch it to your boss and they say, well, did you think about this or that? So identify what those risks are and then talk to us and see, is there a way that we can mitigate those through either adjustments in the product or the way that it's tested, the way that it's deployed, or through other products that might be a better entry point into the system. So I think that's pretty much all that I have there. And with that, have a good evening.